Alright, so we're going to jump into covering 5.2 today, which is analyzing discrete random variables. And I've put a blue star by the main points we're going to cover on our big ideas that we saw yesterday when we talked about 5.1. So in this setup, we're going to talk about at the top there, our mean, which is equal to our sigma of x times our probability for x. In other words, a sigma is saying your sum of all. So the sigma, that big E looking figure, is meaning the sum, okay? So you're taking the sum of your x values times the probability for that x value. And then you're going to add them all together. Which then leads us into being able to interpret it by saying for many, many trials, the average of whatever we're talking about context-wise is the value we got. Then we're going to go into talking about how to interpret our standard deviation. Now hopefully you've either used a calculator or Excel or Google Sheets to calculate your standard deviation. And when you're asked to interpret it, you'll make this statement. A randomly selected value will typically differ from the mean of the context, whatever you're talking about, by about the value you got for your standard deviation. So again, the big thing is a randomly selected value will typically differ from the mean by the value you get for your standard deviation, okay? That's the big key thing to understand about interpreting. You're going to read that. That's what they're talking about, is standard deviation. We're also going to cover our histograms again, all right, which is something we dealt with at the beginning of the year. So we're going to talk about histograms again, in which case our y-axis is going to handle our probability values, and then our x-axis is going to be our x values, okay, or explanatory variables, right? Explanatory variables. The big thing to talk about this too with histogram is describing the shape overall. So after you've actually been able to draw your histogram, you need to describe the shape to give the audience a visual of what you're actually talking about and how it plays out according to the probability scope. Alright, so let's go into a problem and talk about this, see what it looks like. So Indiana University, Bloomington, posts the grade distributions for its courses online. Students in business statistics in a recent semester received 45.7% A's, 36.2% were B's, 13.8% were C's, 3.2% were D's, and 1.1% were F's. The students' grade on a 4-point scale with A equaling a 4 on our values right there is a random variable x with its probability distribution. So again, what they're referring to here is they're telling us that our 4 is an A, and then we've got our 3 is a B, 2 is our C, a 1 is a D, and 0 is F. So now we've got all of our grade values there, dealing with pretty much like your GPA we talked about, alright? So now it wants us to make a histogram of the probability distribution and describe its shape. Well, when they're giving you the values like this, it's not too hard to really do. So let's go ahead and draw this out. Get a different color here. It's a little bit easier. Alright, so we'll go ahead. The y-axis right here. And then we'll get our x-axis going along here. Alright. And I'm going to say this is our zeros, our F's. I'll say here we got our 1s, 2 C's, 3 B's, and our 4's are A's. Now, what is this down here? Of course, we'll just label these since they label it up here as our value. Let's go ahead and just label it value. So we gotta label our x and our y axis, alright? Don't leave it blank because, well, we won't know what you're talking about. Now, over here on the probability side, right? We're going to label this probability because we know it's going to be probability. I'm going to abbreviate it so I don't have to write sideways so much. So probability. Now, with that, as far as looking at the scale here, we're going to be looking at the values here for our probability. And what is the highest probability value we got? Well, we got 0.457 is the highest it looks like it goes. So we need to get up to, let's say, 0.5 overall, our probability over here. So I'm going to do that. I'm going to say this is going to be 0.1, 0.2, 0.3, 0.4, and 0.5. Alright, so now that we've got that all taken care of, now we just need to draw our bars for our histogram, remember? Now, with these, they have to all be touching. It's not like a regular bar graph where they're separated. In a histogram, the bars actually touch, because it's talking about a range of values, right? So with this, we're going to say our F's here went for 0.011. Okay, so 0.011, that's pretty dang low down here. So we're going to go ahead and just make this a little bitty bar right there. We're going to say it's pretty low. We'll go halfway in between these guys, make it look a little bit easier, alright? Now, for our 1 values, then we went up to 0.032, so went up a little bit higher. Okay. For our 2s, we went up to 0.138. So we jumped above the 0.1 there. We're going to be somewhere in here. You can draw over the middle part of this. For our B's, our 3 value, well, we went up to 0.362. So we're going to need to take this, connect this bar, 362, somewhere right in there. Looks about right. Okay, and that gives us our B values. And then for the A's, we went to 0.457, so almost up to that 0.5. And so we're going to say right around in here was good enough. We'll go over about right there. Now, with that, we've got a great histogram there. Looks wonderful. No complaints. That's all you need to do. You need to label your y-axis, your x-axis, put your values in there, and then make sure you're connecting all the bars to make it a histogram. Now, what's the last thing we need to do here that it says, and what we talked about in the big idea, is describe its shape. So again, remember, people look down at your feet. What foot does it look like? Where's that big toe at? It looks like your left foot, right? Because you're going, your pinky toe going all the way up to your big toe, right? So with that, if you've got that type of drawing and layout for your histogram, then you are skewed left, like your left foot. So skewed left. Skewed left. That's what we're looking at for this one, okay? So let's look at the next question here. So now it wants us to calculate and interpret the mean of x. So again, that was dealing with what we talked about in the big ideas, as far as when we looked at this right here for our mean. Right? We had the sigma, in other words, the sum of all of our x values times our probabilities. And then our interpretation is for many, many trials, the average of, in this case, I believe we're looking at test scores, right? Overall test scores, or overall course grades, was or is going to be whatever we find out to be. So let's look at that and see what we can come up with. So calculate and interpret the mean value of x. So with this, again, to find our mean, that is going to be our sigma for x values times the probability of each one of those x values. So what that's meaning is, don't let that freak you out. Just because there's a big E here and you don't know what it is, don't let it freak you out. You're taking your x values, so our x values are right here. These are x values. And these are our probabilities. I want to use red. Why did it change red? These are our probabilities of x. Okay? So we're going to take 0 and multiply it times 0.011. And then we're going to add. And we're going to then take the value of 1 times 0.032. And we're going to go so forth with this. Alright, now that we've got all of those written out, and hopefully you've seen that you can probably spell those in a calculator, make it really simple, but in this case they want us to show some work here. So since we did this and we understand how it should be calculated, you should be able to put that in your calculator and you should come out to get a 3.222. And that's what I got in my calculator when I put that in there. So that is meaning, or that is our mean, right? That is our mean value, 3.22. So then we need to write out the interpretation, right? Because it wanted us to interpret. We calculated, we got that done. Check. Now we need to interpret. So for this, if many students were selected, their average grade point is 3.22. So overall is the grade point average. So if many students were selected, their average grade point is 3.222. Alright, so again, as I've written out there, if many students were selected, their average grade point is 3.222. Alright, so let's look at one last section here for this. So the standard deviation out of those values, they've already put that in the calculations here, is 0.879. So it wants us to interpret this standard deviation. So to interpret this, as we did up here in our big ideas, we're going to fill those missing blanks in that we have here. So randomly selected value will typically differ from the mean of what we're talking about by whatever standard deviation. Well, in this case, we're talking about the grade point, right? So we would say a randomly selected student has a grade point that typically differs from the mean of 3.222 by about 0.879. Again, a randomly selected student has a grade point that typically differs from the mean of 3.222 by about 0.879. And that is how you need to interpret a standard deviation. So again, we've learned how to interpret our mean value, and we've also learned how to interpret our standard deviation. Those are two important interpretations to put in your notes. So again, we went over how to calculate our mean value for these, as well as how to interpret it, as well as our standard deviation. Once we have our standard deviation value, if it's not given to us, we use our calculators or Google spreadsheets or Excel to calculate that and come up with our value, and use this interpretation to fill in the missing blanks. And then again, refreshing on how to make a histogram and describing the shape is important. Alright, so making a histogram with your probabilities of your y-axis, your values are going to be on your x-axis, and then we're going to describe the shape overall. Alright guys, hopefully you learned a little something and got a good little recap, and I'll see you next time.